Good morning. This is Introduction to Algebra for Monday, April the 13th. We're on lesson 107, and I know several of you asked me to do some distributions of algebraic terms, adding of like terms, and surface area. We are going to discuss those and review those for you today, but first we're going to look at our lesson. All year we have talked about the fraction times the of equals the is, or the percent times the of equals the is. Today, this lesson is very simple if you can grasp one concept. Okay? Write on your paper, fraction times of equals is. Now, I want you to understand when we're talking about a decimal equivalent, we change that word to rate. That's it. Okay? We've been saying our percent, if you remember, we would say the percent over 100 times the of equals the is. This percent over 100 is a decimal, right? So we're going to change this and we're going to call it the rate. So I'm going to erase that and I'm going to write the rate times the of equals the is. It is the same thing. We're not doing anything different with it. There's no special rules. All it is they are telling you when you have a decimal equivalent in the numbers that we're using, that they're going to call it a rate. Okay? Look at our problem on the board. 20% of what number equals 160? That should be a question mark. Okay? So we have some key words that we've used all along. And that is the word of tells us to multiply. The word is tells us that's where the equal mark goes. We also know that we cannot multiply, we cannot divide a percent. So what's the decimal equivalent of 20%? 0.2. So in this case, what we just learned is this 20%, the decimal is 0.2. We're going to call it the rate, okay? So we're going to say 0.2 of means to multiply. What number? We're going to put an N for the number. Equals or is 160. Now, you know what to do with this. 0.2N equals 160. Doesn't matter that this is a decimal. We're simply going to still do what? We have an equation. So we're going to do the opposite of what it says. It says to multiply. So we know we're going to divide. It says multiply by 0.2, so we're going to divide by 0.2. So we're going to divide by 0.2. This cancels, leaving us only the n. Now, we have 160 over 0.2. Remember, Mrs. Turner told you, when you have a division problem written like this, 160 over 0.2, whatever's in the top has the furthest to fall. We're going to always let it fall into our box, okay? I'm going to go over here because I don't want anybody to be confused about how to divide a decimal, okay? We have 0.2 divided into 160. Remember, whatever's in the top goes inside our box. Now, we have to move our decimal point. We cannot divide with the decimal there. We're going to move it over one place. If I move it one place in my divisor, I must also move it one place in my dividend. Okay, this is the divisor, this is the dividend. Okay, so now I say 2 goes into 16 8 times, and we know that 2 times 8 is 16. We subtract that out, we get 0. Since 0 is less than 2, I can bring my next number down. 2 goes into 0 0 times, and 0 times 2 is 0, still a 0. 0 is still less than 2, so bring my next number, which also is a 2. I'm sorry, so a 0, 0, 2 goes into 0 0 times. So my answer is 800. Okay, so when I look at this, 20% of 800 equals 160. I could even go back and check that if I want. Let's look at the next one. This time our percent is missing. So what percent of 40 is 120? Guys, fill in what you know. What percent? I don't know what percent, but we're going to call percents what? Rates. Okay, so we're going to say the rate, the word of means to multiply. That's the next thing I'm going to write. Of 40, so write the 40. Is means equals 120. So the rate times 40 equals 120. What do I want to get rid of? I want to get rid of the 40. It says to multiply by 40, but I don't want to multiply by 40. I need to divide by 40. So draw your line, divide by 40. Whatever you do on the left, be sure you do it on the right. This is going to cancel. All that cancels, leaving me only the rate equals 120 divided by 40. 120 goes into 40 how many times? Okay, so we're going to put it over here. We're going to say 120 divided by 40. So Mrs. Turner, I can do that without writing it out. Well, that's great, because what's it going to be? Our rate's going to be 3. Of course, you could have gotten rid of your 2 zeros and just said 12 divided by 4 is 3. That's all there is to it. You're going to follow the same pattern. Change the word decimal or percent to the word rate. Follow the words. Follow the words. Do what it says. Now, let's look at this. I want to do a little bit of review on using positive and negative exponents. We know that we can't have a negative exponent to solve, okay? So we started working on a few of these the other day. We said 4 to the negative third, okay? In order to get rid of this negative third exponent, the negative 3 exponent, okay? Think about what this means. It means 4 over 1, right? To get rid of the negative, I simply use the reciprocal. So I'm going to say 1 over 4 to the third power. Let's try another one. We have 3 to the negative second. What does that mean? 3 to the negative second is over 1. What's my reciprocal? It's going to be 1 over 3 to the positive second. Okay? Look at this. I have 1 over 2 to the negative fourth. What's the reciprocal? Flip it upside down. We have 2 to the positive fourth. So, Mrs. Turner, what happened to the 1? Remember, all whole numbers are written over 1. I don't need to write that down. It's not wrong if I do, but I don't need it. I have 1 over 5 to the third. This becomes simply 5. This was 5 to the negative third, so now it is 5 to the third power. Now, I want us to look at distribution here. We're going to multiply with some distribution, okay? We have 3px times p plus x plus 2px. Here's what you have to do. Let me remind you. You take this term, 3px, and multiply it only by the p, okay? So if I have 3 times p, there's no coefficient, right? So I'm just going to bring the p down, the 3 down. P times p would be what? P squared. X, there is no x to multiply. So I just bring the x down. Now, I'm going to bring my plus sign because that's what's next. And I'm going to multiply the same term at the beginning times x. So is there a coefficient? Well, the coefficient of x is just 1, right? So 3 times 1 is 3. P times x. And I can't do that. So I just bring the p down. Now I say x times x is x squared because there are 2 of them. Bring down your positive sign and say 3 times, oh wait, this one has a coefficient. So 3 times 2 is 6. Put your 6 down. Now p times p becomes p squared. And x times x becomes x squared. And that's how you do the distributive property. Let's try this one. We have mn squared times m plus mny plus 3m squared. Okay? So we have mn squared times m. Okay? There's no coefficients to worry about. So I say m times m becomes m squared. N squared has nothing to be multiplied by, so we just bring it down. Keep your sign and do the same thing. M times m in y, I can say m times m and get m squared. Then I have n squared times n, so how many n's do I have? I have 2, now I have 3. So I have n to the third power. I don't have a y out here, but I have one here, so I can't ignore it. I just bring it down. Plus mn squared times 3m squared. There's only one coefficient, that's the 3. Since there's no coefficient written, we assume that it is a 1. So 1 times 3 is 3. So our coefficient is 3. Now say m times m squared, and you have m cubed. Then you have n squared times nothing, so you have n squared. Okay? I hope that helped a little bit with the distributive property. We're going to now look at adding some like terms. I'm going to flip over here and find one real quickly. Here's one. What if, move this, okay? What if we have this? Write it down on your paper while I write it on the board, okay? What if we have m squared n cubed plus 3n m squared n minus mn squared plus, we have to erase a little more of our board, okay, plus 2n cubed mm. Okay, now let me read you the whole problem again. So we have the same thing written down. We have m squared n cubed plus 3n m squared n minus m squared plus 2n cubed m. Now, if these are difficult for you, a couple of things I need you to remember. Number one, you can only combine the coefficients and squares and cubes if the letters, the variables, are exactly the same when you're adding, okay? Number two, you can break them apart so that it's much easier to see if you struggle. So let's do that, okay? What does m squared n cubed mean? Well, it means m, n. It means 2 m's and 3 n's. Okay, let's go to the next one. We have 3, and it has m squared, and n. Remember, I said I like to put all my things in the order, okay? So we're going to put our m's first. We're going to put m, n. Remember, I'm multiplying m times n times n. I can put those in any order I want. So I'm going to put them, number one, alphabetically, and number two, all the m's together, all the n's together, okay? Minus, now I have mn squared. What is that? It is 2m, so mm. Now I have an n, and then I have an n squared. So I have 3 n's. Look at the last part of this. Bring down your coefficient. Put your m's first, Now you'll put your 3 n's. Now we're going to go back and look at this. How many of these terms are exactly alike? What am I looking at? Not the coefficients. The coefficients are the numbers. We don't care what the numbers are right now. We're only looking at the variables. We're looking at the letters to make sure the letters are exactly the same. Okay? I have 2 m's and 3 n's. I have 2 m's and 3 n's. So this one and this one are the same. I have 2 m's and 3 n's. This one is the same. I have 2 m's and 3 n's. All of these terms are the same. Okay, so what am I going to do? I'm going to first look at my coefficients and say 1 plus 3 is 4, minus 1 is 3, plus 2 is 5. Now, I have to look at my m's and my n's, okay? I have m squared n cubed. That's what my coefficients give me, okay? Now, I'm adding all of these. So if I'm going to add them, I can't just put this down, okay? Look in your, that's because I want to show you something. Look in your book at lesson 106, problem number 19. Lesson 106, problem 119, okay? Some of you are trying at this point, after you've added your coefficients, to try to go back and add all of the m's and n's, okay? Look at this problem. We have m squared n cubed. This is what we wrote on the board, okay? And then we have 3n m squared n minus n squared plus n cubed mn. The only thing you're doing is you're breaking this all apart to say which ones are already exactly the same. If they're exactly the same, add the coefficients, put those letters back with it, and leave it alone. We're not adding all of these. A couple of you tried to add all of these. This is our answer, okay? We're not going to add. When we add these, we're actually going to be multiplying. We're going to get there, but right now, when you're adding like terms, you want to make sure the variables are exactly the same. Break them apart if you need to. For some of you, you don't need to do that. You can say, okay, I'm actually going to simplify this, okay? I could have just as easily, guys, instead of breaking them apart, I could have simplified it. I could have said, excuse me, m squared n cubed plus 3. Oh, this is m squared, and there's 3n, so that's n cubed. Minus, oh, there's 2 m's, that's m squared. N's, well, there's 2 here plus 1, that's 3. Oh, these are all m squared n cubed all the way across. And since I'm adding and subtracting, the only thing you're adding and subtracting are the coefficients. If no coefficient is written, it's the number 1. I hope that's a little more clear than it was the other day for you. Because of time, we're going to have to stop, but I will do surface area, I promise, Zorella, tomorrow, okay?